All right, let's check out the I changed my mind about this language.
I changed my mind
with
about
low-level learning because this is actually really exciting. And hey, guess what? At the end of this video, we're going to actually get low-level learning in here, and we're going to have a quick discussion on this. So this is going to be a double whammy today, a double whammy, because low-level learning, if you don't know, Ed, as some people call him, kind of the man, okay? It's kind of the man. Here we go.
About Zig. Originally, when I started the code in it about a year ago, I wasn't sure if it actually had a meaningful place in the developer ecosystem.
Oh my goodness, I feel so justified already. We're like 2 minutes in. I even made videos about this. I don't think Zig has a good place yet. And I still stand by that opinion because it's like during like 2 years ago, the hype was all Rust, right? It was all Rust. It was all exciting. Everybody wanted Rust, and it was all about safety and all these kind of things. And, you know, I largely agreed with that. I thought that, okay, if I'm going to program some sort of new low-level systems-level language, I might as well actually have something that is fast, but also really dang safe, and I'm not going to shoot myself in the foot, and I want, like, one really expressive type system. So it's like, well, Zig's not as safe as Rust, but then on the other side, it's just like, okay, but it's easier than Rust. But then you're like, well, if I wanted something easier, I could just use Go. So where does Zig sit? What's the purpose of Zig? And the more I got to learn about Zig and kind of let it stew in my back brain, comp time, plus the ability to have options, and plus errors. So it does do results. It does do error. It does do options and results, and that there's like a couple different situations in which you can still do a nil pointer. But for the most part, it's more like Go and it's more like C than anything else. And so I was just like, I felt like Zig had no purpose. And now I'm like, Zig might actually be the real de facto one. And I do mean that I think Zig is significantly more interesting in embedded work than Rust or C. I think Zig would be significantly more interesting as a web server than Rust. Go is like it's a huge argument. I think Go and Zig is a much more compelling argument to have than Rust and Go. I actually think that Rust, the more I learn about Zig, I even think the Linux kernel made a mistake having Rust going into it. I think Zig should have been the one that goes into it. I really do think Zig is actually the most interesting language out there right now. I really do. It just seems so super cool. It does. I think it is just so super cool. I cannot believe how cool it is, and I've just been stewing on these and reading a little bit here and there. Obviously I haven't done a lot of it. I've just read about it and played. I think I did a couple days of Advent of Code last year in it, and it was just so cool.
System. And as I've been using it and being asked more and more questions about it, I think I've come to a better conclusion. In this video, we're going to talk about what Ziglang is, where it lives in the developer ecosystem, and my thoughts on the syntax and the features of the language. Now, if you're
This is good. This is a good lineup because I have a lot of thoughts on these things. By the way, I feel like people have the worst measurement of what is good and bad syntax. People come in constantly and they're like, Golang has the worst syntax. Golang doesn't even have syntax. Like, what are you talking about? There's like 5 characters that are just English letters. It's just pretty much ASCII. It's just a bunch of keywords. It's wild. It's wild. The only thing that people can say, they're so mad at colon equals. Like, I think colon equals is the only thing that people are mad at. Hey, I don't like implicit returns, right? I don't like the last thing inside of a function being the thing that returns, oh, it's an expression-based language. Well, guess what? My parser, it looks for keywords, okay? Okay, my dyslexic-ass brain looks for keywords, and so it's very easy for that. So colon equals is not a problem because there's 2 instead of 1. It's very easy. It's very, very simple, okay? Whereas no return is hard for me. I have to like look for extra stuff. I don't know. Seems hard. Anyways, but we all don't like syntax for different reasons, but I'm very curious about that one. Okay. Haskell has shitty syntax. Can't you invent your own syntax in Haskell?
If you're new here, hi, I'm low-level learning. I make videos about software security, programming, and cybersecurity in general. So if you like that stuff or just want to hang out with me, hit that sub button. I really appreciate it. Now, a lot of new programmers ask me, oh, what language should I learn? Should I learn C or is C unsafe? Or should I learn Rust or is Rust too hard? Or should I learn Zig? And I think for a long time, I had a good answer about C and Rust, but I didn't really know how to answer when it came to Zig. Zig had this weird aura about it where I wasn't sure what problem it solved, but I think I'm going to be able to answer that for you today. If you consider the ecosystem of systems...
By the way, that is like such a common question, which is Rust or. Should I learn Rust or? And it's always some set of things that people are always weighing against. And it's kind of wild. Like, I mean, if you want to learn Rust, you should just learn Rust and stop Rust-oring it, right? I just think it's kind of crazy to always just living your life on an or, like always trying to find the most optimal thing to learn and all this kind of stuff. Like, it's better just to learn something. Learning something is better than trying to figure out the best thing to learn ever. And I think a lot of people, they end up trying to just learn the best possible thing versus just learning something. And then they end up spending months trying to learn the best thing. And they swap really, really quickly. And they can never quite do it because there's always something new. And so they just never actually learn the thing. It's like the most common thing I see. Flip, you might be able to keep this in. It's like one of the most common thing I see is that people constantly try to just live the most optimized life. And you probably just, you don't need to do that. You know, I always say this. You know what's better than the best workout ever? The one you're going to do tomorrow. If you can just keep on having something you're going to do again, that's better than the thing you'll do once. Then do it again. Then do it again. Then do it again. And then maybe you'll be kind of excited to improve. And if you're excited to improve, okay, you know, exciting.
Programming, you have the C language and you have Rust. Now, those are the two main ones that stick out in my head when it comes to systems level languages, and we're not going to talk about C++, by the way. Now, there is Go. Go is another compiled language that is very, very good in getting more and more speed, but Go is a garbage collected language, and some systems, some platforms, and some projects require that you don't use garbage collection for one reason or another. Garbage collection is inherently non-deterministic, so a lot of the times people will just choose to not use a garbage collected language. Now, you're left with...
It's fair, factual. But Go is garbage collected, not garbage. Go's a great language. Most people, they just simply need a tool for automation or a tool to aggregate a bunch of results together and do something. And you can do quite a bit with Go. You can just do quite a bit. And so I'm not too worried about it. Yeah, this whole, like, you can disable the garbage collector is very interesting. I'm curious about that. If you disable the garbage collector, what can you do with memory? I'm not really sure. I don't know. It seems interesting.
The basic two, you have C and Rust. Now, each of them have their pros and their cons, their shortcomings and their power, right? C, on the one hand, is the OG language. It's been around since like 1972 or whatever, and it's one of the best languages that exists in terms of the power that it gives the programmer. I mean, the entire world, to include every embedded device that exists, your router, your fridge, your microwave, is probably written in C, and that...
He is right. People forget how good C is. I mean, the time and place C was created, but not only that, it can perfectly express almost every single computer science problem. And so it's not only a great just like language that people have used for many years, but it's also a really great representation of just computer science itself. It's like the manifestation of all the algorithms and data structures and everything. It's quite a great language. C is a great language. It is a great language. Coffee machine is in C, probably. There's probably just a really small amount. It might be in something else, but it's small. Hot take? I don't think that's a hot take. I think that most concepts in computer science boil down to being very well expressed in C.
It's because C is an incredibly powerful language. The programmer is able to do literally whatever they want. As long as it's within the scope of like what the OS, the kernel allows, it's able to be done in C. Now that is what I'm considering on like the far left of the spectrum, right? You have like powerful, but do whatever you want. Think of it like chaotic evil language, right? On the other hand, you have Rust. Now Rust is designed with so many of the failures of C in mind. C, for example, is not a memory safe language. You can exit outside of the bounds of an array. You can do arbitrary use after freeze, and it's on the developer to catch them at compile time or the program to enforce that you can't do those things at runtime. But you can very easily write code that just allows you to do whatever you want and have it go out into the ether and become a security vulnerability that eventually gets hacked by hackers. But if you consider the new program...
By the way, that is skill issues right there. You know, don't get caught by skill issues. It's that easy. C is great, but then C++. C++, you know, I think C++ gets a bit of a bad rap. You could do quite a bit with C++ that's not bad. I think the thing is that C++, like a lot of languages, they offer a whole bunch. You know, I mean, to be real, have you ever used some Rust that when you look at the code that it produced, like that the person produced, you look at it and go, this is just crazy code. This code is absolutely crazy. And you get completely confused by by what is happening. Like, I mean, when you look at really high performance Rust, it's pretty wild out there. And if anybody tells you that Rust is way easier to maintain, you know, I'm not 100% convinced about it. I mean, I've worked in some pretty awful C++ code bases. I spent 2 days trying to figure out a logging thing, and I couldn't figure it out. I tried like I tried my hardest. Couldn't figure it out. Could not do it. The macros were too intense. A Clang D couldn't keep up with all of it, and it just fell apart. So I know what bad C++ looks like. Is high perf Rust as insane as high perf C++? I feel like Rust is 100% harder in the high perf situations. I feel like it's much harder. High perf Rust is slower and harder. I don't know if it's slower. Slower is kind of I don't know that. But hard is very hard.
Programmer who's trying to get into the space, who wants to learn a language that is for systems programming, but doesn't want to do Rust because Rust is too hard, but doesn't want to do C because C is unsafe. Where do they go? This is where I think Zig fits in very, very well. Now, what you're looking at here is a project I've been working on.
Interesting. That's actually, for me, that's not a selling point. Though that is a selling point, that's not my first selling point. This is kind of an interesting approach to kind of going about this as a language first, or this as the reason first. Okay, I can curious. On
Twitch, I've been basically trying to reproduce the XXD binary. If you don't know what XXD is, it's a basic hex dumper, right? You can specify the size of the columns and the size of the groups. And what you do is you pump in arbitrary data into there and it hex dumps it, right? Pretty straightforward. I use this project as a way to learn new languages because the project itself is very simple, but it forces you to learn a few things about the language. You have to do like basic loops, memory views into binary data, how to open files. You have to use the parts of the API that may be like non-standard. And then also like, it's just a cool tool to have. I think it's pretty neat. So anyway, what I'm doing.
I've never built XXD. That could be neat. That kind of seems like a neat project. That sounds like a neat one to do stuff. Like you can see a lot of cool stuff in Zig. Like I do love their try syntax. So for those that don't know, I will say it's both good and bad. Having, I don't know what the term is for, not postfix. I'm not sure if it's prefix, if that's the term for it, but to have try first and then your statement is really nice. It's really easy to read what's going on. But the postfix question in Rust is really, really convenient for chaining. Is that an exception try? It's not a try. So when you see the word try or catch, it's not what you would consider it. If you think of try, try is unwrap in Rust. Try is not unwrap in Rust. It's not at all unwrap in Rust. See this little bang void? This bang void, what that means is that this function can return nothing or an error. And so try fstat will forward up that error. It will return it. Try is equivalent to the question mark operator. This is a result object that comes out of this function. So bang void is a result object where the type is void. So it actually has a result object. So Zig has a result object, which I think is pretty cool. I see Alex and no free. What is this? Well, I do see an alloc right here, and then I see a free right here. So this defer is a free. So you get defer, which I also think is really nice. This allocator doesn't do something, and then it just dumps the hex. That's probably fine, right? Try is a bubble up the air, yeah. And catch is kind of interesting because if you open the path and you can't open it, you can then do something on not being able to handle the error, which is also kind of like a super cool concept. I actually really like this concept where you can do something and then handle if it doesn't work out. Rust error handling is just the best. I don't know if that's true. This is super cool. This is equally, in my opinion, there's some things about this that is actually cooler than Rust's. Right? The try, not as good for chaining. Not a big fan of that. But most of the time, if you're chaining a bunch of errors together, I have a lot of questions. That's pretty difficult. Whereas this catch, I think, is super cool. Like this is super, super cool catching. It seems like a more elegant version of Go error handling. It has the result objects that you always want from Rust, but it has a much more like kind of Go-y feel. And so this is kind of what I want. No chaining. You can't really chain as easily. It's true. It's harder to chain. It's just harder to chain. I haven't done Elixir error handling, so I don't know. The combination of try catch with error unions is very nice in my opinion. I agree with that. It's very, very cool. It's very, very cool. So people that don't know this is very cool. It's the middle ground between go and try catch. Well, no, it's not. There's no try catch. It's not try catch. It's not throwing errors. Right? It's not throwing errors. Zig errors are only enums. You cannot attach payloads to errors. I'm not sure what that means, a payload to an error. I don't know what that means. You can chain things that all return errors types. I don't know if you can do that. Anyways.
Doing in this project is reproduce.
You could by like surrounding it by parentheses, but that's not really chaining. Try catch was good, and we should use try catch. I do not think, I think this is where Uncle Bob and I will permanently disagree. I do not think try catch is a good paradigm. I think try catch is terrible. I think try catch is 100% bad 100% of the time, no matter what. Anyhow, good luck. For those that didn't see that, that was really good. This is most people's Rust error handling. Rust has great error handling. Also, anyhow. Just anyhow all the time. Anyhow, bail. Anyhow, bail. Anyhow, error. Anyhow, this. Anyhow, that. Anyhow.
Using XX.
How do you even create an error in Rust? Nobody knows. Nobody has any idea. It's unheard of.
And this is the current status of it, and I'm calling it ZZD, so pretty neat. In doing this project, I learned a few things about the language that I want to talk about that I really enjoy. First is the main feature that kind of separates Zig from C. So if you have written C recently, right, C used to be, basically it was...
Sorry, someone just said something very offensive in the chat. Dinebox, impl error. I mean, this man's out here. First off, it's incorrect. It would be box dyn error. Okay, it would be a result of e box dyn error. Okay, now that, my friends, is an evil statement. This is an evil statement. This is also how I did my first Rust error handling. That's how I did my first one. Try catch is useful in certain situations when you know certain exceptions will happen. Yeah, you know it's even easier if you know when certain exceptions will happen. You can also use errors as values, because the only difference between this and what you're saying is that errors as values, you know where they all happen. With exceptions, you only know the ones you know. You know what I mean? And it's just like you only know the ones you know. Let's go back a little bit.
Just a cool tool to have. I think it's pretty neat. So anyway, what I'm doing in this project is reproducing XXD, and this is the current status of it, and I'm calling it ZZD. So pretty neat. In doing this project, I learned a few things about the language that I want to talk about that I really enjoy. The first is the main feature that kind of separates Zig from C. So if you have written C recently, right, C used to be, basically it was literally an abstraction for assembly. Instead of writing assembly, you would write C, and the C would just turn into assembly. That'd be it.
They say that when the heap was introduced, programs became hard.
Like no extra things added. There was no allocators that were created. You had to write all that stuff yourself. As C got older, as C matured, we now have like the glibc library that does a lot of stuff for us. We use printf, we use scanf, and all of that stuff that when you use it,
I like to call it glibc. Glibc way too much. I like to call it glibc. Okay, feeling a little glibc tonight?
Gets buffered in the heap. So Zig is trying to prevent these things that they call ghost allocations, where when you run code in Zig, all the allocations will be ones that you ask it to do. It will not do any allocations for you. And because of that, they've given you very explicit access to these things called allocators. So you can write your own memory allocators that allocate memory in the way that you would like it to be allocated. You can write your own kind of heap. You can write a basic stack allocator. You can basically do whatever you want, which is really cool. Another thing is this defer macro, right? When you're doing allocations, every allocation, when you do an alloc, must be met with a corresponding free, right? If you don't do that, you have a memory leak and your program is buggy. This defer keyword allows us to do the associated free for that piece of memory, and it makes them close together in code. So when I'm doing a code audit, I can look at it and I can be like, okay, cool, I have my alloc here. Where do I free this variable? Oh, I literally, like on the next line, I do it. The defer keyword allows this piece of code to be ran when the function scope is about to go out. So when I run defer, this actually effectively puts this line of code at the bottom of the code, but it puts it up here so I can mentally associate that this is tied to this, which I like.
So you have to write an allocator for every object? No, there's general purpose allocators, there's specific type of allocators, there's a whole slew of different allocators, but you can even use glibc, C allocator, all that kind of stuff. But the big but in this one is that, and it's something I really like, which is all objects created on the heap are known at programming time. To me, that's really important, because that's one thing that you have to learn about Rust, which is you have to know which ones are on the heap and which ones are on the stack. So when you do in Rust, when you do a string, is that on the heap or on the stack? When you do an RC, is that heap or stack, right? Like you learn all these things, and it's not hard to learn. But you still have to know these things. You have to walk through it and learn each one of these things one at a time, which is very interesting. You know, so that means if you do an RC ref cell string, which would make no sense, by the way. But let's just pretend you did an RC ref cell string. You'd have to kind of, you'd have to know where, like, how many heaps are you on? So it does make you have to think about things a little bit. Whereas with Zig, you know all the things that are allocated, which I think is really important. I do like that. I actually really do like that paradigm. I think it's nice. I think Rust makes it feel nice. The problem with Rust is that it makes you feel like you're programming a high-level language, but you're not. You're programming a low-level language, and I think that mentality is a bit of a foot gun for those that are uninitiated.
Like a lot. The next big thing that I was a really big fan of is the errors as values feature of Zig. Now, if you've written any Rust, you have the result type, the OK type, and error type, right? Where the result is a enum that allows you to basically return either an OK, which is a good value, or an error, which is a bad value, and then handle the output via pattern matching. Zig is a very verbose language where you are required to not only use all the variables that you name, but also you're required to handle all the errors that you get, right? So effectively, this open file function has this return type. What this return type actually means is pretty interesting, and I love the notation of this. On the right of this exclamation point, you have the return type when it's a good value. So the correct return type is this. If there is a return error to be returned, this is the error type, right?
So that's equivalent to result standard fs file, comma, standard fs file open error. Like this is you can think of it effectively the same.
And so what we're able to do is we're able to run the open file function and effectively think of it like we go left or we go right. In the case of we go left, the open file good value, the standard fs file, is put into f. Easy, that's awesome. If we go to the right, we're able to check to see, okay, we've caught that we're in a file open error, and that type has different subtypes, and we're able to print them out via basic pattern matching. I think it's really cool. I think it's a way for you to be forced to handle every error case of your program, which in languages like C, for example, like a lot of the times, you don't even have to check the return value. You can just say like, open, and then if it's good, it's good, but if not, it can crash. Like it doesn't, like no one cares. So I like this a lot.
It's true. You just are like, what's your error no? What's the error no? Like error no was a problem. Okay. Can we all agree that error no was a problem? Open sets up, shoot. Right. So no more OK value. So really, you don't think so? Dude. Okay. So at one point, error no was probably really great. I'm sure of it. But you know what's way better is not having global where's my error. Okay. You know what I prefer? Local, where's my error? Okay, I'm not in here. I'm just not in it. You know what I mean? I'm not in it. Hey, thanks first time chatter for your CBD heals autism and psychosis and epilepsy. I appreciate your very insightful first time chatting. That sounds fantastic. Do you have a product I can purchase? Is this a CBD commercial? Do. I used to have autism until I took CBD. We have to give some Java some credit to arrive at the throws. Do we? I don't. Well, I mean, yes, we can give Java the credit. I just don't want it. I just don't want any throwing. That's why I like this. I love this. This is good. You have to handle your errors. Handle your errors, baby. This is good. CBD is actually a new JS framework. Oh, CBD.js. It's like THC.js. Just more legal.
And you don't this last part I think is really...
You don't get as much spaghetti code.
Interesting. Zig is not explicitly a memory safe language. Like you can do the traditional thing where in one function you create an object and then you return a reference to that object, and then when the stack goes out of scope, you have a reference to a dangling pointer, right? Like that kind of thing is allowed in Zig. But what I do like about Zig is that it gives you things that smell.
That's good. I mean, in some sense, to me, that's good. I do like the fact that if you're using a systems level language, you should have, I do think there is something to be said about systems level controls in system level languages. A SME, I think there is something very, footgun's good. Well, no, what I mean is that you can do what you need to do. I mean, obviously that is bad. Like I would love it if it prevents it. There's probably some sort of warning, like, I mean, even C has a warning, right? Like, hey, dog, you're returning a reference to a stack allocated variable, like, you sure you want to do this? I don't think this is a good idea. I don't think this is a good idea, right? And I like that. Shared mutable data is important. Yeah, I actually do agree with this.
What I do like about Zig is that it gives you things that smell or like taste like memory safety that prevent a lot of very simple bugs. Like for example, I have the dump hex function, which is doing the basic, print out the data as hex. And what I'm doing is right now I create a chunk, and the chunk is always the same size. Right now the chunk size.
This is super cool, by the way. I don't know what clit is, but this is super cool. I've never found one. This is super cool what you're about to see.
This is 2. And I have a little bit of an edge case where basically I'm able to index outside of a chunk where the value is undefined if the size of the file is odd, right? So if I have a file that is 51 bytes, on that last iteration, I've only read in 1 byte of data, and I can iterate into the second byte. So basically I have a very basic out-of-bounds array access. Now, in a language like C, this would just be okay. We'd just be all right with this happening. There'd be really no, I mean, there's a way to check it. We can make sure that we do the math and do the calculations to determine if we're outside of the array bounds. But in Zig, when I run this code, there is a runtime panic. It can see, despite not being explicitly memory safe, that I am indexing 1, the value 1, so I have line of 1 into a slice that is length 1, right? And so instead of giving me some weird seg fault where it's doing an array access that the OS can see, it's going to throw an error at this level. And this is a much, I think, safer way to crash, right, than, potentially going outside of the array bounds like C would let you do. Now, what I'm not saying is that you shouldn't learn C. What I'm not saying is that you shouldn't learn Rust. You should learn C, you should learn Rust, and you should learn Zig. Like, I think everyone should learn all the things. I think learning is the way that you become a
I like that. I like that quite a bit.
A better, not only developer, but a better person in general. Now, that being said, if you have limited time, I think obviously you should be picking one, and that choice that you make just depends on what you want to do. If you want to be a systems level programmer, despite the movement towards Rust, things are still written in C. And if you want to get a little bit...
And the nice part is that Zig really compiles well with C. A lot of people are actually building their build tools for C in Zig just because it's so good. It's like so dang good. It's like Zig is so good at this, that area. That the next, no more make files, no more CMake, just use Zig.
A little bit of a taste of what I think the future of coding looks like and what safer software looks like. Try Zig and try Rust. I do have courses at lowlevel.academy. Go check that out. Link in the description below. If you want to follow along with me on my journey and figuring out my thoughts, my additional thoughts on Zig, go follow me on Twitch. I stream there like once a week. If you like this video, do me a favor, hit like, hit subscribe, and then go check out this video. We'll see you next time, guys. I appreciate it.
Liked. Boom. Let's go. Okay, there's one thing he didn't cover. So I kind of want to take like almost an inverse take on some of the things he said. Some things that I really like about Zig. Zig also has the optionals, right? I think long as there we go. So you can actually say like, hey, this thing could be null, and for you to be able to have it, you could actually like this. So you get syntax available for options. But it's not as heavy-handed as Rust. And it's also able, you can also do like an if statement, right? So let's see if they have a capture group. There you go. Here's a great example. You can do an optional of 5, and then if B, then you capture out the internal value. And to me, this is, I know there's like if let sum x equals your option that. This just feels less heavy-handed. It feels pretty nice. Like I think that a lot of things with Zig is like almost Rust. It's like you're almost to Rust, but it's a little bit let. It's a little bit less. And it makes it really nice. Oh, I forgot the let. If I forgot the if let. Yeah. If you forget the let, you will spend like a minute going, what the hell's this error? What have I done? Right? Syntactic sugar, that makes sense. This is really, there's like a lot of really nice little features of Zig that make it super compelling. And it's something that it's why I really want to look more into it. And then another thing that is just, I think is just genuinely superior is comp time is like super, super duper interesting. It's just really bizarre. Like right here, running a Fibonacci sequence at a compile time, right? So when we compile, it runs this, and you get that. You get the value out. X at compile time is the result of this Fibonacci sequence. Comp time is super, super interesting because comp time you can also define types. Let's see if they have any example of this. I would just like to see this. There you go, a vector. A vector is now going to have some like cool things inside of it, so you can actually create your own vector, right? I want a vector of size 3. This is now a compile time. Look at that. You have a compile time with how many elements are inside your vector and the type. Like to me, that's super cool. So it's almost Rust macros, but you don't have to have a doctorate in Sin. Instead, you can have comp time, which is just writing Zig. You're just writing Zig. So you get to write Zig without all of the macro nonsense, right? Because if you really want to get good at Rust and you really want to understand a doctorate in Sin, no, not that kind of Sin, not S-I-N, S-Y-N, syntax. It's like they're great for being able to do procedural macros. Procedural macros are like pretty tough, right? Procedural macros are definitely like your level 3 learning of Rust. You first have to start off like learning syntax, borrow checker, and all that. Level 2 is like you have to go learn async and lifetimes, and then level 3 is like proc macros. And proc macros are really, really difficult. Yeah, I've never played. I haven't done anything deep with Zig yet, but this is just super compelling because it's like I want to be able to write generic structures in a way that makes a lot of sense to me, and that seems pretty cool. This seems pretty dang cool because it's just Zig. You just write Zig to execute a compile time to produce Zig. Yeah. Once you, by the way, also when you turn level 3 Rust Station, you also have to dye your hair blue. It's one of the requirements. I hate to tell you this. It's just one of the requirements. Okay, so now for the second half, which I said, I'm going to bring on low-level learning. And we're going to chat for a moment. I'm calling him right now. Sorry, it's just part of it. I'm sorry. Can I just shave my head instead? No, you can't shave your head. You cannot shave your head. It's not allowed in the Rust area. You have to keep your hair no matter what its balding state is, okay? So if you're going deep in the back and you're Homer Simpsoning, like you got a Homer Simpson, you know? That's it. Did low-level learning just like dip right now? I should have his phone number and I just call him and be like, "Hey, get on here." I called the Mr. Clean, so C++ doesn't exist. C++ doesn't exist. C++, okay, Flip, you got to take this intermediate part out. But C++, I will say that with the introduction of unique pointers, you can write nicer code in C++.
Hey, what's up? This is incorrect. Hold on a minute.
I know, I can't see you.
Yeah, I got the OBS virtual cam going on. Go like that. Boom.
And oh, nice. No video in.
A good time today. I don't know why it's not working. Yeah. Are we gonna cooperate? Hey, there it is.
Did you just say, are we gonna cooperate?
The computer. Yeah.
Oh, I thought you were saying like me and you. I was like,
no.
Collaborate.
Oh,
nobody calls it cooperate.
Dude, I can barely read English. Okay, so even if I said that, I apologize.
Okay, I believe I beat you on the barely read English. Okay,
dude, I haven't finished a book in over. Actually, I just finished a book. Before that, it was a couple of years. So I'm like kind of illiterate, functionally.
Functionally speaking, you're kind of illiterate?
Mm-hmm.
That's okay. Hold on, I'm trying to, okay, I'm going to show this. Hopefully there's nothing. There you go. I actually have this already preset out. There you go. Look at that.
What's going on, dude?
Hey, how's it going? All right, so
Good.
we just got done watching that video, which I liked a lot of it. There's a lot of stuff that was really cool about it. I think, what do you think is the primary reason for learning Zig? I know you kind of said it, but I don't know if I really feel the thing you said, or maybe you try to like make it too tight. What do you think is the primary purpose of learning Zig?
Yeah, I mean, so you have to understand it from my perspective, right? I am a security researcher, and I'm trying to get to a world where people just naturally write safer code. And a lot of the time, you have this thing where the argument is, oh, it's a skill issue. Like people who just get better will write better C. And I think that's true to a certain extent. But it ignores like the human factors aspect of programming, where like new people are going to come in, they're going to not know how to code, and they're going to write production code that goes out. So how do we create a language that just naturally allows for safer code? And the quick answer is Rust, obviously, right? But I think Rust has a lot of systemic issues or like parts of the language that make it very difficult for a new programmer to get into. Whereas Zig, I feel like, has the same like flavor of Rust and like Go-esque languages, where it is safer, but because of the lack of a borrow checker and a little more freedom that you get versus Rust, it's just easier to get into. So in terms of like choosing like the best first language, I think for me, Zig is more and more getting there in my head. I still think you should learn C, but in terms of like production code, I think Zig has a special place, or should in the future.
I do want to double tap a little bit on that Rust statement you made. You said that effectively that Rust is really hard to get into as a beginner. The thing about it, my general take of the Rust learning curve is that it starts out hard, it gets easy, and then it gets harder. not easier. It actually gets significantly harder the moment you start jumping into async and you start jumping into any application that's of some certain level. Now, there's people that just build like Rust web ends, and all they are just like taking a, you use Axum or Actix, and you write a basic like CRUD endpoint, and it actually works really well in Rust because all of that abstraction and difficulty has been hidden away, and you don't even really realize you're on some sort of like, you don't even know what thread you're running on or anything. It just works, and you're just like, oh, this was pretty easy. But I feel like the moment you try to write those things, it's excessively difficult, and generics can get really, really, really hard. Working with trait objects and generics is like it is non-trivial, and people that think it's trivial. And then it goes to a third level, and then a fourth level. And I feel like the difficulty of Rust is a lifelong learning process. And for me, that's kind of like a big issue. Is that if you're developing something that's simple, I feel like Rust can be pretty fun and easy, and you'll be very successful. In fact, I would argue that you would be even more successful. Basic kind of like churn in your product, and you're still not developing something hard. It's just like a lot of churn. I still think Rust is a pretty good language to choose.
Sure.
But if you have to do the things yourself, I just don't buy that Rust is I think Rust suffers from the same skill issues that C does. If you just got better at Rust, you'd be better. It'd be easier. It's just skill issues, and it's just like, is it just skill issues?
I think at the end of the day, I think you need to put in hard work regardless, right? I think like every language, like you're going to encounter some amount of inertia where like you are not going to get better until you push through this wall. But I think in Rust, it's the wall enables language functionality, and in C, the skill issue is security. You can publish pre-skill issue code in C. It's much harder to publish pre-skill issue Rust, if that makes sense.
That's fair. Yeah, I mean, it's still easy to create like a memory leak. I actually created a memory leak and broke my server.
but even in Rust, right? I think like you can create memory leaks in Rust, but you can't create memory disclosure leaks in Rust, right? Like the idea of like leaking the heap to a user that shouldn't have that heap data is very difficult. And then on the topic of, I agree with you in terms of Rust, right? Like I did some Rust code on Twitch. I built like an HTTP server. It's very simple, and I'm like, oh, Rust like actually isn't that bad. Like you just you create some structs, you create some traits, you write some functions for those traits, and you're good to go. But then I went on further and I tried to do embedded Rust using Artic. It's an RTOS that's like a framework for the STM32 chipset in Rust. And
I've done a bit of embedded.
It immediately gets like exponentially harder, where it's like suddenly you're dealing with lifetimes and trying to take peripherals from a chip, and then you want to give other parts of that peripheral to a different function, and you can't pass those around very well. So like I agree, like it's deceivingly easy at the beginning, and then it very quickly ramps up, and it's like, oh, if I want to do real code with this, like it's going to get a lot harder. Again, you could put the time in and get better at Rust, so that I do agree that the skill issue exists on both ends, but I think if you want to get to code that's like you can publish it, Rust has a little bit steeper of a curve than C.
Yeah. So with that, and you said Zig is easier, do you think the same skill issues, I mean, can you even make those arguments with Zig? Like, hey, for you to be able to build a high-performance HTTP server, I feel like that would be excessively difficult. Like, what Axum has done in Rust would take me a year of just doing it full-time to be able to probably get to that point.
Yeah, so full disclosure, I didn't use any of the libraries in Rust. I like raw dogged, like take TCP socket, parse HTTP 1.1 headers, send the data, right? So like
just
very
registered
basic.
Nurses?
What's that?
Registered nurses?
What is that? What?
/r/n.
/r/n. Okay, I was like, what are we talking about right now?
Yeah, I know.
Oh my god, yeah, a bunch of registered nurses in my packets. Yeah, dude. And it was pretty simple, right? But then the minute you get to anything more complicated, it's tough. What that did is it gave you access to like learning the network API, learning how to parse, like do basic string iterators, stuff like that. Yeah, because the entire protocol is registered nurses, right? Yeah. And I think in Zig it would be similarly simple, and I think simpler because you wouldn't have a lot of the borrowing issues. Now, granted, in that scenario, there's not like a lot of borrowing that can happen that can go wrong, right? You literally pass around a single request structure to multiple functions, de-encapsulate it, re-encapsulate the response, and go from there. And I think Zig would just be a little more straightforward because it feels more like C, less like Rust, where Rust has kind of like, that there are weird edge cases you're going to run into. I didn't get that sensation when I coded in Zig. That being said, though, Zig is much more verbose of a language where like you have to use all your variables, you have to handle every error type, you know what I mean? Whereas like you could go write C, don't have that issue. And I think even Rust is more permissive than Zig is in terms of like the variable use policies.
Yeah, you get a warning, I believe, instead of a error. You get a hey unused variable warning, and then you can just prefix it with an underscore.
Yeah, right. But that's the thing. That's why I like Zig so much. Is it forces you to think through your error handling schemes from the get go. Like it does not let you get away with. I mean, that's not true. You can do the try statement in Zig just like you have the dot unwrap in Rust, right? So I mean, like you can do that.
Those aren't the same though. Those aren't the same.
Aren't they pretty similar?
No, nothing is similar. Unwrap panics if it's an error. Try returns the error up one level. Try is more equivalent. Try is much more equivalent to the question mark.
Oh, I see. Okay.
You're running everything in main, so it makes sense that it like the end.
Right.
But if you were to put it one function inside, you would actually get more like the question mark operator. It just lifts the error one level.
Interesting. No, that's a good point. Okay. Yeah.
Either way, catch is so cool too because Rust doesn't have syntax for catch.
Right.
You have to like match. You have to do something, right? And so it's actually pretty interesting. And also like catch unreachable is the equivalent of unwrap. You're effectively saying like this is like it's an infallible operation. You cannot get here. If you do, and that's why I like the error typing system, right? Like you have the return type that says like go left, go right, and then the left is a good case, right's a bad case. And that's where all the catch pattern matching happens. So yeah, like you're saying, it allows you to give kind of two paths in your code to go down, one the good path, one the bad path. Whereas Rust, you have this weird kind of mixing of the two based on the way that the matching statement works. So yeah, they do have some convenient functions. They have like and thens and maps and all that stuff. And so and okay, a lot of people will just dot okay because that just makes it you don't have to handle the error at all because it turns it into an option and you can just ignore options.
Yeah,
just forget that option.
Forget about it. We didn't see that. It's all good.
Forget about it.
Yeah.
So it's interesting. Have you done much async Zig?
No, I've not done much async Zig, nor
either.
Async Rust. So that's kind of my next thing is to explore the async frameworks. In particular, I'm going to start doing Embassy in Rust because that's the async framework for embedded. So I figure jump into the deep end, see what that feels like. Yeah.
Okay, because once you go async, you go arc mutex all day, baby.
And that's where I heard kind of Rust decomposes, right? It's like once you have the arc mutexes, it's like, okay, are we still in Rust or are we doing some other weird meta language, right?
Yeah. It's very interesting because one thing that I really like about not Rust is that you can have a mutex, like say on an object, and you can lock and unlock it where you kind of wish to lock it and unlock it, right? You get the choice of saying, hey, this is a controlled mutation under this mutex. Whereas with Rust, you just that cannot be an option. You have to put more or less items underneath a mutex, or you have to protect a singular property, or you have to lift all the properties you want to access out into some sort of read-write mutex, which I find to be very, it can be very cumbersome. Whereas,
it's just counterintuitive.
It is counterintuitive, and I feel like it just is a giant performance foot gun. Whereas like you can actually, for the most part, just be like, I know exactly what I do and don't want to mutate, in parallel on this object. So for the most part, I can just like rip through everything, and then these couple ones are all controlled by one mutex. But it's like you have to like uplift things into structs. It's just more tricksy.
And that's kind of my philosophy, and I think it stems from the fact that I'm like a huge control freak, right? So like I feel like Zig gives me the control that I want, and I have like the very explicit knowledge of what is going on, and that's their whole memory model, right? Is like they are trying to avoid the world of glibc ghost allocations. Like every allocation that happens in the program is an allocation that you wrote, and same thing with the mutexes and the set. Like everything that is done is because you decided to do it explicitly. Whereas in Rust, I think a lot of those features, even in a compiled systems language, gets kind of lifted, like the mutex example, which I'm not the biggest fan of. And again, my whole philosophy on learning is like you have to know what is going on under the hood, and when you create those kinds of abstractions, it kind of, I think, it adds too much fairy dust that takes away from the learning process, in my opinion. So
can you do? Someone's asking about ghost allocations. Can you give like a brief? What is a ghost allocation? How does it happen? Can you give a?
Yeah, I mean, so C is the when it was designed, it was built to be an abstraction from assembly, right? You have to do everything explicitly. Like when you make a variable allocation, that just creates an assembly blob, right, to make room on the stack. A ghost allocation is this thing in glibc where the glibc runtime is creating memory allocations without your permission in the background, right? Like if you do a scanf call, for example, right? The scanf call just reads in memory to a buffer and returns that into the buffer that you pointed to. But the memory that it's used to actually buffer it before it outputs it is allocated in glibc, right? So it's an allocation that happened that you didn't ask for. And that happens all over the place in libc. and is used to, you know, like there are ways you can exploit that from a security standpoint. Like a lot of heap exploits have to do with abusing memory that is allocated for you in the glibc runtime. Whereas Zig, it doesn't do any of that. Like to make an allocation, if memory is allocated in Zig, it's because you told it to. There's no other memory getting allocated, which I think is a cool feature because you can kind of predict more reasonably what your function is going to do, what your code is going to do.
Okay. Okay. One more question. When it comes to learning and all this, do you think that Rust, you know, I'm not going to say the word masquerading, but, you know, like saying, hey, we are a systems level language. Do you think the fact that you don't ever really think about allocations as kind of your initial pass, do you think that hurts learning the system level's thought process? Meaning that when I create a string, I don't think necessarily this thing is now pointing to the heap. I mean, I know you should understand these things and how the difference between, you know, a stir and a string versus like an RC or a ref cell, like all these things. Like, what do you think about that? Because that's like, it's like the polar opposite of Zig. Zig is like every allocation you know you've made, whereas Rust is like every allocation we're not going to tell you because we're going to also drop it for you.
Yeah, I mean, I don't think it hurts the learning process in the short term. I think like abstractions are valuable because otherwise I would just say good code in assembly, right? You know what I mean? Like, oh, if abstractions are bad, just go learn how to like build silicon and build a computer. So abstractions are good, but I think if you want to truly understand, it's important to go back, like to circle back and go learn like the difference between a stir and a string, like how slices are actually working under the hood, how that affects borrowing and all that stuff. So does it hurt learning? No. But is it hurtful to ignore those abstractions? I think yes, in the long run.
Very cool. Very cool. Yeah. Any last thoughts on Zig? Any last things you want to?
Yeah, it's cool, man. It's a good language. I'm having fun with it, trying to learn it myself. I think the only major issue right now, and I've read a lot of this on Reddit, is the documentation. Like, it's not great. I mean, there are docs, right? There's like, you can go read the standard library docs, but in terms of like examples that show you like implementation, it's kind of in a weird spot right now. That being said, it's pre 1.0, so it's still in a very early like alpha-ish stage. So I give them a lot of credit for that. But no, man, it's really, really cool, and I think it's going to have a really unique position kind of in between C and Rust that'll help people learn systems programming without relying on C as like their first language. So yeah, man, that's about it.
All right. I like it. I like it. Cool. Well, hey, thanks for being on here. I like the video. People should subscribe to you. Anything else? Any other shilling you would like to do?
Any other shilling? Oh, I will shill away, my guy. Yeah, I mean, so hey, if you don't know who I am, I do videos about security and software security and programming in general on YouTube. I stream on Twitch. And if you want to learn C, I have a site called lowlevel.academy. I teach C there. It's a good time. Come learn C with me over there. Boom. That's it. But yeah, man, I appreciate you having me on. Thanks for watching the video. And let's do more stuff.
Yeah, I do want to do. I want to do more stuff.
Cool. Oh, also, I bought some coffee. I'm looking forward to it. I'm gonna roast it. But yeah,
nice,
it's gonna be great.
This is our very first batch.
Yeah.
I think we're looking to switch. We're looking to switch some roasters and kind of think about other ways of doing things. So we got a lot of work left to do on that because it's all non-trivial.
Oh yeah, dude. You know? The fact that you guys are even shipping physical products, I'm impressed with, because like most online sales are like, oh, drop ship, like pay money and then I call Alibaba and they send you a thing. But you guys are like literally pouring the coffee into the bags. Like you got a real operation going on over there. It's solid, dude. We're
trying to understand things at a fundamental level and then going from there and trying to, make it into something. But we'll see. Yeah, we'll see how it works.
Cool. Well, I'm excited to try it.
Bye-bye.
Later, brother.
All right, there we go. That was awesome. I like Low Level Learning. He's great. He's a great guy. Hey, the name is Low Level Fan. Oh, Low Level Fanagen. Low Level Fanagen. Fajin.